For today's class, I wanted to talk about a couple of different optimization problems that I want to be able to cover. I wanted to do a couple of quick examples. The first one I want to cover is on the screen right now. Suppose you want to build 10 separate pens for animals. All of the pens should be side by side. Each pen should have 30 square feet of area. What are the dimensions of each pen that minimizes the amount of fencing you use? Essentially, what I mean when I say that you're going to build 10 separate pens side by side is that you're going to build sort of a bank of pens. Something like this, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pens there. Okay. And essentially each one of these pens has to have an area of 30 square feet. And what we want to do is we want to minimize the amount of fence we use. Okay. So, any ideas as to what our constraint or our objective looks like? Vivek, I saw you light up your mic, but I didn't hear anything from you. So what type of function should our objective be? What are we trying to maximize or minimize?
Hey, can you hear me?
I can hear you, yeah?
Oh my god, okay, cool. Um, I was gonna say our constraint would be the 30 square feet of area.
Yeah, so the constraint should be will be an area equation. And one way of doing it is to say the area of one pen is 30 square feet. So what's the objective? What is the thing that we're trying to minimize here?
The fencing.
The fencing. And that's a perimeter, right? So the thing about this problem is that there's actually really two very reasonable ways to set this up. One is to consider all 10 fences, all 10 cells or pens as one large unit, right? Or we can consider them all independently and individually, okay? So if we want to consider the pens as an entire unit, so we're considering all 10 pens as an entire unit, then we'll take our sort of image here. Whoops. 1, 2, 3, 5, 6, 7, 9. And we'll let the width of the entire bank be X. And we'll let the sort of height of the entire bank be Y. Okay. So in this case, our constraint will be the area of all 10 cells together which will be 300 square feet, right? Will be equal to the area of the entire rectangle, which is x times y. And in this case, our objective equation will be the amount of fences we have of length x and the amount of fences we have of length y. So our perimeter will be 2x plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11y. Because we have 11 lengths of fence of length y. And this is the thing we're trying to optimize. Our other option is to consider one individual pen. So consider each pen individually. We still have the same picture. 1, 2, 3, 4, 5, 6, 7, 9. Okay, with 10 boxes. But then instead, our Y length will be the same. It'll still be the horizontal or the vertical length here. But the X length will be the width of one pen. So our constraint then is x times y is equal to 30. It's the area of a single pen, right? And our objective will be that the perimeter is equal to the number of fences of length x. This time there's a lot more of them, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20 of them. So it'll be 20x. And we'll still have the same amount of y lengths, plus 11y. Both of these examples are actually totally identical if you're solving for, if you eliminate x, and they result in the same answer if you eliminate the y. Okay. Any questions about these two setups? All right. So we can use either one of these that we want. I'm going to choose to use the first setup, I think. It feels more natural to me. So let's use setup number 1. Our objective is P is equal to 2x plus 11y, and our constraint is xy equals 300. So that means that x is equal to 300 over y. So our perimeter is 2 times 300 over y plus 11y. Or P is equal to 600 over y plus 11.
Could you scroll back up for a quick second, please? Thank you.
Yeah. Is that far enough?
Yes.
I will be able to post this whiteboard after the exam as well, or not exam, sorry, the class. So I'll post a PDF of this file that I'm writing on right now.
Okay, I'm done. Thank you.
So, okay. All right. So from here, what's our next step? What do you do after you've rewritten the objective in terms of the constraint?
Take the derivative.
Take the derivative, all right? So let's go ahead and take the derivative of our perimeter equation. So P prime will be, again, as usual, 600 over y is equal to 600 y to the negative 1. And when we take its derivative, we end up with negative 600 y to the negative 2, which is negative 600 y squared. Sorry, over y squared. So our derivative is negative 600 over y squared plus 11. And then we're going to find our critical point, right? So 0 is equal to negative 600 over y squared plus 11, which means that 600 over y squared is equal to 11, which means that 600 is equal to 11 y squared, and 600 over 11 is equal to y squared. Take the square root of both sides, and we end up with a critical point at y equals the square root of 600 over 11, which is something along the lines of 7.39.
Wouldn't that 600 be negative?
We added it to both sides there. So it was negative to begin with, right? And then when we added 600 over y squared to both sides, it came to the other side as positive.
Then wouldn't that make the 11 negative?
Why would the 11 be negative?
I don't know. I'm just looking. I thought it was because it was like that 600 on top, and then I thought when you like multiplied it, wouldn't you wait? Can you just add negative 600 even if it's on the top of like a?
Well, we're not adding negative 600. We're adding negative 600 over, well, we're adding 600 over y squared. Right? Like we're adding this whole quantity right here.
Oh, okay.
So it'll cancel out with the negative version of it on the right-hand side and end up on the left-hand side.
Gotcha.
Yeah. And we probably do want it to in fact be positive, because if it was negative, then our answer would be imaginary, and that seems like a bad time. All right. Is everyone else satisfied with our y value here? 7.39. All right, so we do need to check and make sure that this is in fact a minimum. So what we can do here is we can take our, I'm going to do a second derivative test. So P prime was equal to negative 600 over y squared plus 11. So P double prime is going to be 1200 over y cubed plus 11, or plus 0. And when we plug in P double prime of about 7.39, we can plug that into a calculator if we want to. Let's clear that. So 1200 divided by 7.39 to the power of 3. And we get about 2.97, which is certainly positive, right? And so that means that P is concave down at 7.39. So y equals 7.39 is a minimum. Sorry, concave up at 7.39. So y equals 7.39 is a minimum of P.
So if it was concave down, it'd be a maximum?
Yeah, so concave down means that the concavity is on the bottom side of the function, right? So that means it has to be a maximum. And concave
Gotcha,
up,
gotcha.
yeah, means the concavity is on the top side, which means that you get.
Is it always concave up when it's positive?
Yes. Your second derivative being positive means that your function is concave up. Second derivative being negative means that your function is concave down. The second derivative being 0 technically doesn't tell you if the function is concave up or concave down. It could be both, it could be neither. Or both. It could be neither, or it could be one or the other. You can't be concave up and concave down at the same time. They are mutually exclusive conditions. But second derivative of 0 doesn't tell you what the concavity is, so you can't tell if your function has a maximum or. So the last thing we need to do for this question is we just need to check and see what we were being asked, which was for the dimensions of each pen. And the dimensions of the pen, we need to go back, find that, and give our answer, right? We know the y coordinate of each pen, right? We know that y is this distance here is going to end up being 7.39. Each pen has an area of 30 square feet. So that means that 30 is equal to, let's call it the width times y. So 30 is equal to the width times 7.39. So the width of each pen should be 30 over 7.39, or about 4.06. So each pen should be 4.06 by 7.39 feet. If you do this problem using the other setup, the second one here, then you end up getting to the exact same place. You can do either setup and solve for x instead. Note that if you do the first setup and you solve for x, you're not actually going to get the dimensions of one of the pens. You're going to get the entire length of the thing. So you'll need to divide that by 10 to get the actual width of each pen, right? So you just need to be careful and make sure you're answering the correct question. Any questions about this problem? I have seen versions of this problem where they say like, oh, and then in the corner of each one of these intersection points, you have to have a post, and the post is costs $5, and then the fencing costs like $3 per foot. What's the minimum cost? It turns out that these problems are all they're identical, because no matter how you build this, the number of if you're building them side to side like this, the number of posts you pick will always be the same. You're never going to be able to have more posts or less posts. So that's a constant cost. So as soon as you take the derivative to find your rate of change of your cost to try and identify a maximum or a minimum, that constant cost will just fall off. Okay, if there aren't any other questions, I would like to do one more problem. So this problem, it has to do with a piece of paper, or a poster actually. So a printer, here the profession, not the office supplies object, needs to make a poster that will have a total of 600 square centimeters area. The poster has margins of 4 centimeters on the sides and 3 centimeters on the top and bottom. What dimensions for the paper maximize the readable area? So what we have for this is we have a poster. It's on a piece of paper, right? And not all of it is going to be printable or readable, right? We have to have some margins, okay? So basically we're going to have a central bit of it that's actually printable. And the top and bottom margins will be 3 centimeters. And the side margins will be 4 centimeters. So when assigning variables, we're asking about the dimensions of the actual paper, right? So it seems nice to me to assign x as the horizontal width of the paper and y as the vertical height of the paper. What is the thing we're trying to maximize here? What's our objective? And what is a constraint that we have?
Our objective is to maximize the readable area.
Yeah, so the objective is to maximize the readable area, right? And what is the readable area? Well, it's this center rectangle, right? And what are the dimensions of this center rectangle? Well, what's this length here? At the bottom.
Is it just x minus 8 centimeters?
Yeah, because we've got 4 centimeters on the left and 4 centimeters on the right, so this must be x minus 8 centimeters. And what's this vertical distance here?
Y minus 6.
Y minus 6. So our max readable area will be the area of that, which will be, let's call that R, is equal to x minus 8 times y minus 6. And what's our constraint equation? Well, our constraint is the area of the actual piece of paper. The piece of paper has to take up 600 square centimeters. So our constraint is that the area is 600. And the area of this paper is x times y is equal to 600. So we can now we can take our objective and rewrite it using the constraint. So r is equal to x minus 8 y minus 6, and xy is equal to 600. So that means that y is equal to 600 over x, which means that our r is equal to x minus 8 times 600 over x minus 6. This is the thing we're going to take a derivative of. I don't think I want to take a derivative of it the way it's currently written, though. You can just use a product rule and go ahead and go straight for this. So you can use a product rule now. But I would rather distribute. So r is equal to x times 600 over x is 600. Negative 8 times 600 over x would be negative 4800 over x. X times negative 6 is minus 6x. And then negative 8 times negative 6 is positive 48. So the 600 and the 48, when we take our derivative, those are just going to go away. We could combine them if we want to. But r prime will be 4800 over x squared. Again, same rule for the derivative here. We're secretly going and making it x to the negative 1, all that stuff. That negative sign will cancel with the negative we get from the power rule from x to the negative 1. Minus 6 from the 6x. And again, the 600 and the 48 will just disappear. Is everyone okay with this derivative?
Yes.
Okay. So now we need to set this equal to 0. So that means that 0 is equal to 4800 over x squared minus 6. We add 6 to both sides. We get that 6 is equal to 4800 over x squared. And then we'll multiply both sides by x squared to get 6x squared is equal to 4800. Dividing both sides by 6 tells us that x squared is equal to 800. So x is equal to, I think this one ends up being 20 square root of 2. it is.
Plus or minus, right?
You are technically correct, yeah, and that would have been true for the last one as well. Why can we get rid of the negative one?
It wouldn't make sense to have negative margins or readable area.
Yeah, well, yeah, in this case, the area of our paper has a width of x, right? Can you have a paper with a negative width?
No.
Nope.
No. So we can get rid of the negative one. But you are correct in that algebraically there are two solutions. There should have been two algebraic solutions for the last one as well. But again, we're only dealing with the possible positive ones. Okay. And this ends up being about 28.28 centimeters.
Wait, how did x squared equals 800 become x equals plus minus 20 square root 2?
So the square root of 800 is the square root of 4 times the square root of 100 times the square root of 2. 4 times 100 times 2 is 800. And that's 2 times 10 times the square root of 2, which is 20 square root of 2. You don't actually have to have this part. You just need to have, you could have just done the square root of 800 and plug that into your calculator. That's fine. Right, that's what I did in the calculator over here. You could have also done, so 20 times the square root of 2 is the same thing. They're equivalent expressions. Okay. So at this point, we just need to answer our actual question, right? We need to go back, we need to take a look at the question, and we need to figure out what our exact answer was supposed to be. And we'll notice that our answer is to be the dimensions for the paper to maximize the readable area. Oh, wait, no. We technically need to verify that this is a maximum. So again, the second derivative test is nice. R prime was equal to 4800 over x squared minus 6. So R double prime will be 9600 over x cubed, negative 9600 over x cubed, minus 0. 9600 divided by the last one, or the square root of 800 cubed, is, with a negative in front of it, is a negative number. R double prime of 20 square root of 2 is negative 0.4242. So R is concave down at x equals 28.28. So R has a maximum at x equals 28.28. Since x has a maximum there, or since r has a maximum there, that means that it's what we're looking for. And now we need to answer the question, right? So we need the dimensions. We know that 600 is equal to x times y. So 600 is equal to 28.28 times y. So 600 over 28.28 is equal to y. So 600 divided by the square root of 800 means that y should be about 21.2 centimeters. So in order to maximize the readable area. Our paper should be 28.28 by 21.21 centimeters. And those are the last two basic types of problems that I need you guys to be familiar with for this exam. So I will post another set of problems. I have 8 more problems for you guys to check out. There are examples of these two types of problems as well. So I encourage you to go through those. Like the last sheet, these optimization problems are relatively representative of the type and difficulty of problems that I will provide for you on this exam. So if you feel comfortable being able to do these problems, then you should be okay on the test. So. And for those of you who came in a little bit late, the exam is going to be open book and open note, but you will not be allowed to work together or with anyone outside of class. So basically, you can use whatever notes you want, but you cannot speak to it. I will ask for you to not speak to another person about the test. So no working together with your classmates, and no working with any tutors or outside help sources. So. Or posting questions on like Stack Exchange or something.
If you would say, what is the best tool to use to study for our test?
Probably your notes. Probably the stuff I've posted, like the questions I've given you. They're pretty similar. So.
And what about that review sheet you just posted?
Same. Like, that's what I was referring to as something that would be good for you to do. So.
Where did you post the review sheet again?
I'm about to. So there's one on D2L. I think I already posted on D2L. I'm not sure. Oh, I posted last semester's version of this midterm. Our version will be a little bit. I think the questions will be a little bit more difficult because you're going to have as much time as you want, and you're going to have, access to like whatever calculator you want and all your notes and stuff. So I'll probably give you slightly tougher questions. So I posted a last semester's midterm 3, which is equivalent to this test, and I'm about to post a bunch of problems for you guys to look at in D2, both in D2L and here. So.
Sweet.
Okay. Are there any other questions before I let you guys go?
So those questions on the review sheet, those are not the ones we've been working on?
I have another review sheet that has more problems similar to those. Both sheets are valid.
I had a quick question about
Yeah.
the project.
Yes,
So
project stuff.
the next step is due on Monday, right? This upcoming Monday.
It is due, a week from today. So the same day that the exam is due. So you guys need to be at this point. You guys by Wednesday you should have a survey put together, and then so that you can maybe post it on Wednesday and hopefully get some results by the weekend. Okay.
Gotcha. Thank you.
So it's going to take a little bit of time to get results on that. So you should try to get ahead on this one. Don't save this one until the last minute.
I thought you said the survey was due
Monday. The Monday that the exam is due. That's April 13th, which is next Monday. Any other questions about anything else? All right. And as a quick note, as Alex noted, server notifications, I think by default you get notified every single time anybody posts anything anywhere. You don't need to live that life. I've noticed a handful of you have discovered the busy function of Discord that blocks notifications, which is nice. That's totally fine. You can also, if you go under your options for a server, like if you right click on the server and then you hit server settings, you can mute servers and you can change notification settings. So if you feel like you're getting spammed or you're worried about getting spam notifications, feel free to check out those options.
So Aaron, you can turn off notifications for an entire server, like
you
on
can.
your side.
You
You
can.
can as well. It just you can't choose specific channels to turn off.
Okay. I don't want to turn off notifications for the entire server period because I want to have notifications. So I'm going to let you guys handle that on your side because I know those options are available to you guys as well.
So, but is it fine? Like me, Alex, and Lawrence, we kind of were working in it was the classroom section, and I kind of posted something. Was that
That's
fine?
fine. Yeah.
Okay.
Yeah. Again, if you are getting too many notifications from the channel, then feel free to mute things. I can look into making it by default, muting things that are not at notifications or like mentions. But I'll look into that a little bit more. Okay. I am going to go ahead and stop the recording and let you guys work on some stuff. I will post some problems and into Discord as well as D2L for you guys to look at first. So